Hey guys, welcome back. So in the last video, I was removing the M46 shifter from my 77-242, and I realized that the shifter did not match, or the shift knob did not match the transmission that came with the car, and we had to do some customizing to make it fit correctly. In this video, I'm going to actually be taking apart that shift lever to replace some of the worn pieces in it, including the reverse lockout shift rod. And also I'm gonna try and attempt to fix the nicks and the dimples that were created on the shift lever ball from the lack of bushings before. And then if we have time, I'm going to try to turn it into a short shifter as well. So I'll get right down to disassembling the shifter now. The first thing you want to do is to take the knob off, and the knob should not be glued on there. If it is, someone else messed that up. It should just pop right off. Just give it some firm pressure and it should pull off, and then just set it off to the side. The next thing is the lock collar for the reverse lockout, and after that you should be able to look inside the tube. It's a two-piece assembly, the shift lever. The top piece is held in place by a bushing, and it's usually a roll pin, but mine had this clip instead. And then it has pressure on the spring and the reverse lockout switch lever there. So I'm going to go ahead and remove my clip here, and if you have the stock roll pin, what you would do is try to find a similar diameter tool and just press it out on one side, and just try not to mar it too much, because you will need to reassemble it and use that in order to keep the two pieces of the shift lever together. But once it's out, the top chrome piece should slide right up. And again, there should be two bushings in there, one at the top of that and one at the bottom where the pin goes through. And so once you have the top half of the shift lever disassembled, you can slide the spring off, as well as the reverse lockout thingamajig, and then the reverse pull rod as well. These pull rods are all, I think you can only get them in plastic now. So we'll see if we can figure out something with that. The lower bushing on mine is still in shape. You can see it's shaped exactly like the orientation it should slide into the lower part of the lever. So you shouldn't get that mixed up. And this piece is also in correct shape as well. The pull rod I will have to replace. I happen to have the 6-inch version, and I think there's two different sizes. So here is the shift lever, completely disassembled, and again, I've shown this a couple of times, I think already. Let me get some light. Yeah, there's a lot of weird scratches here. So what I'm gonna try to do is I'm gonna clean this up and try to fill that in with some weld, and then try to polish it down so it's kind of a ball shape again. Yeah, I don't know if it's gonna turn out, but I do have a replacement shift lever, but they don't sell these anymore as far as I can tell. I think you might be able to find like a complete short shifter version that comes with everything, but as far as just like an OEM metal rod, I don't think you can acquire these anymore. So even though I have a replacement, I'd like to see what I would have to do in the event that I don't have one, or if you can't get access to a replacement one, there might be you might be able to salvage this still. So we're going to clean it up. And there is some stock coating on there, and I think it's either, I can't tell, I think it's either zinc or maybe cadmium plating. Either way, you know, you really don't want to weld onto it, but the areas where I need to fill in are, you know, it's pretty worn. The coating or plating is worn down already, so I don't think I have to worry too much about that. But I will, you know, try to get out as much of that plating as possible just for safety reasons. Yeah, so I'll go ahead and get this cleaned up. Okay, so this is the shift lever after I've welded on it. I am still kind of a beginner welder, so you know, just still learning how to do some of the stuff. And the first pass, I think it didn't have enough heat, and when I turned it up, it started looking a little bit. The penetration was a little bit better, but yeah, it looks like most of the low spots are filled in pretty good. I'll have to just knock this down and then see if I can grind it smooth and round, and if it's still low, I'll add in some more weld and go from there. But yeah, I think this is a pretty decent start. We'll see where this leads us. So the shape is mostly all back. There are some of these little pinholes that where the weld didn't completely penetrate, and yeah, I did make a couple of nicks when I was grinding the excess weld off. But all in all, I think it's gonna be okay. Now I've just got to smooth this out a little bit more and then polish it smooth. Here it is side by side with the extra shift lever that I have, and you know, you could tell that it's obviously not perfect, but I think it's smooth enough to function in the way that it should, without catching on the bushing or anything like that. You know, I wish I could do like a more perfect job, but you know, I don't have access to the machinery to machine it to you know, a really smooth surface. But I'm pretty happy with it. I think it'll work. All right, so to turn the shifter into a short shift lever, we are going to have to extend the section that's below the fulcrum, or the ball. And the more you extend it, the less travel it's gonna have to do, right? But the issue here is that you wanna make sure that you don't extend it to the point where the shift lever contacts the transmission. And an even bigger issue could be the shift linkage just dragging on the top of the transmission case. And this is not normally the type of set screw that you would use. This is what I have laying around. The other OEM style actually goes into it, but I'll just use this as kind of a placeholder. So it looks like I could probably extend it. Let's do 1/2 inch. Let's do, yeah, somewhere between 3/4 and 1/2 inch is where we want to extend. So I actually failed physics the first time around, but let me see if I can get this correct. All right, so the shift lever that we've been talking about this whole time is, it's simply that. It's a lever, which is just a straight bar piece with a piece in the middle, somewhere around the middle, that can pivot, that it pivots on. It's what's known as a simple machine. It's one of the most simple machines, second to, like, say, a ramp, for example. And the direction that the shift lever pivots is going to be up and down on each direction, with the ball section as it's known as the fulcrum. So what the part that you handle is also known as the input section, and the other side that's connected to the shift linkage is known as the output. And if I'm doing this calculation incorrectly, please feel free to correct me in the comments. So this might be a common knowledge to some of y'all, but I have never had a short shifter before, and I didn't really understand all the physics behind it. I was always under the impression that short shifters were easier to shift, but that's not really the case. So yeah, I wanted to get some numbers on a stock shifter before I decided to turn mine into a short shifter. And so what I'm doing here is I'm trying to measure the mechanical advantage of a stock length shifter. I'm measuring from the length of the distance from the fulcrum to the area in which that is connected to the shift mechanisms under the transmission, and the distance from the middle of the fulcrum to where I would be gripping the shift knob. So you have the two distances here. It's 2 inches and 10 inches. And the formula for to get your mechanical advantage is that the top distance, the input distance between the knob and the fulcrum, divided over the output distance, which would be between the fulcrum and where the shift linkage connects to. And once you do that problem, you come up with the number 5, which means that your mechanical advantage is 5. Meaning that the lever actually increases the force applied to it by a factor of 5, and that's pretty good. That's one of the reasons why the Volvo 240 shifters they're so easy to shift. It doesn't take much effort at all. It also means that the distance in which you have to apply that force is greater. So in making a short shifter, you're increasing the section below the fulcrum, and that will take away a little bit of mechanical advantage, and it really just should reduce it down to 4, which still isn't bad. But the payoff is that the distance applied is going to be lessened as well. So I'm going to mark the area right below the fulcrum in which I'm going to be making the cut. I want to make sure that's not too close to the ball, but also not too close to where the spindle pin would go in. So right in the middle is where we want it. I'm also going to use my engraving tool to put a little arrow on this, the two halves. That way, whenever I do weld it back together, you know, I don't have it backwards or facing the wrong direction. I could use a marker, but once I start cutting and welding, those marks can fade. So here is the cut off side of the lever, and here's the area below the fulcrum. I tried to leave enough meat so I could weld onto there without interfering with the areas that are going to be contacting other parts of the transmission. And then here is it's a slightly larger than 1/2 inch piece of metal rod that I'm gonna weld in between there. The diameter is just like a little bit smaller, which I don't think is ideal, but you know, I think it's gonna be the right strength at least, and well, you know, we'll see how it goes. In retrospect, I wish I would have done this before I I repaired the ball section on the fulcrum of the lever, but you know, I did that part first. So we'll go ahead and weld this up. Put back, we've got the top and bottom halves together, and the C-clip and the bushing, and yeah, looking good. So now the shift lever is all repaired and put back together, and I think I'm gonna wait until the next video to actually install it into the car and take it for a test drive, but it's looking good, and you know, I can't wait to try it out. If you enjoyed the video, you know, please click like and subscribe, and I will see you next time. Thanks.